Alright, so I was a little bit held up because I was trying to debug some code that I was practicing. But now I'm done practicing, so now we can start. Let's see. So today we are handling structures, and as I said, I'm not going to focus entirely on the practice problems. I'm going to start with something gentler and more introductory, and then we'll go from there. So I will start with a simple problem statement that I hadn't given you before. Write a program to write a program to figure out if some data points that if a set of 3 points entered by the user will form a triangle. So that's the problem that I am asking you to solve. Let me close this. And this is not something I'd given in the practice problem, so we'll just solve this up front here. So it's a 2-dimensional plane on which we are going to draw the triangle, so every point has to have 2 coordinates. So you will notice that this is essentially the same structure that I have put in the slides as an example. This is the simplest possibility. So if we try to solve this problem without using structures, how would we approach it? Essentially what we would do is we would say include why is this not showing up properly? Let me get rid of this. Include the io.h. I will also need math.h because we're going to be calculating the Euclidean distance. So if we were going to solve this without using structures, what would we do? Essentially, we would say printf enter the first point followed by a scan of a x comma a y, and I would have these 3 points would have 6 coordinates bx comma by, cx comma cy, and then I would essentially just say that and that. So this is how I would get all my 3 data points input, and then I would say print is triangle ax comma ay comma bx comma by comma cx comma cy, and what would this function be? So you can see that it's a little bit tough, and not that tough, but it's a little bit challenging because I have to have 6 parameters um, in this on every call, and also 6 parameters to define it. And here, what would I do? I would say, oh, how would I do this? Let's see. Well, let me say int a comma b comma c, just arbitrarily, and I'm going to set a to be distance ax comma ay comma bx comma by. So I will calculate the distance between a and b. I will add to it the distance between b and c, and I will test if this is greater than the distance between a and c. That is how you test the triangle inequality. And then we have to essentially consider the other possibilities. A comma c plus c comma b should be greater than a comma b. And what is the third possibility? B comma c plus a comma c be greater than bc plus ac should be greater than ab. AC plus BC should be greater than AB. Oh, so then this has to be the third one. AB plus BC, BC plus AC. So what's here? I have 2 BCs, so I can't have a BC here. I have AB. So this has to be AB. AB plus AC greater than BC. So you can see that just in trying to do this, even though I was just working this out before, it's complicated. It's not easy to work through this notation, and then I have to return A times B times C. So if any of these is 0, then it's not a triangle, and if they're all 1, then it is a triangle. That's the idea of the triangle inequality. And then finally, I would have to define this distance between any 2 points, ax comma ay comma bx comma by, and this I would put the Euclidean formula in. This would be return power something comma 0.5 what comma 0.5 power ax minus bx comma 2 plus power ay minus by power 2. So we are squaring, we are summing, and then we're taking the square root. That's the Euclidean distance. So let's make sure that this is correct. Oh, so I have to have this placeholder. That. Okay. So I need a typecast. Anyway, we'll see. So we have this, we have the second point and third point. Fix this. Let's take this and let's say test.exe 0 0 0 1 1 0. So this forms the triangle, and it says yes, it formed the triangle. Now if I said 0 0 1 1 2 2, this is a straight line, this does not form a triangle. It says will not form a triangle. So you can see that the logic is working, and that's good. But we want to handle data type of argument in distance function is not mentioned, somebody says. Oh, you want the link to the lecture. The link is here. Here. Data type of argument in distance function is not. Oh, I see. Int. Yeah, that's true. Int. Yes, that will take care of the warnings. Good, thanks for letting me know. Now if we compile it, it will work just fine. Very good. Okay, now we've seen how we can do this without using structures. Let's see how we can do this using structures. And you will see that it'll make the code so much more elegant. It's just going to make it look much nicer. So we'll say struct point and then we will say int x, int y. So because I'm doing this in Visual Studio Code, the syntax is already built in for me. If you're doing it in Fruiter or some simpler IDE, remember that you will have this semicolon at the end when you're defining the structure. So now we have a data structure that looks like this, a simple point with an x coordinate and a y coordinate. Now how can we take inputs? So let's go down to the main function, and now instead of saying int and then these 6 ints, we'll say struct point ABC. This is going to serve the same purpose as AX, BX, BY, and so on. So those 6 observations. And now we will work the same way, but now we are taking scans here. And so we will use the structure field notation. So where before we had an individual variable bx, now we have a variable b of type struct point, and that has two sub arguments or two subfields, x and y. The subfields are accessed using the pointer notation, the point notation, and so that's how we get to them. So this is now doing the exact same job as what we were doing without using structures. And so far, this hasn't really changed all that much. We still have 6 things to reference. But now, look at what's going to happen here. In is triangle, we will pass just these variables, a, b, c. And then is triangle will have 3 formal parameters of type struct point. So now we have a custom data type. The data type is struct point. So we are passing 3 struct points into the data set. Well, into the function. Now, it's also possible for you, well, actually, let's talk about that later. But it's also possible for you to avoid this clunkiness by saying struct point every time. You could define a macro, or you could just define the struct point as some other entity, but we'll talk about that. So now that you have defined this structure and we've defined a function that makes use of that structure, this will simplify considerably. Remember, when I was doing this, I was having trouble. Now I will have no trouble at all, because now this is going to become completely idiomatic. B comma C, resistance C comma A greater than A comma B, and distance C comma A comma B comma C. So this is symmetric. And then finally, in the distance, what do? We now have 2 struct point data types that have to be passed. And then what do we do here? We do this. And now we have rewritten the code that I had written before to verify that something is a triangle. We have rewritten it using this structure, and you can see that at least in some cases that rewriting is helping us by making the code less clunky and more elegant to read. Now let me compile it. It compiles. Let me run it. I'll use the same points, 0, 1, 1, 0. It works. Let me run it again. 0, 0, 1, 1, 2, 2. It works. So by using this simple structure, I am able to make my code much more readable and much more elegant, and that is when we're dealing with simple static structures of the sort that you will see in, for example, lecture 28, that is the biggest advantage. You are storing, you're essentially designing a custom data type that is appropriate for the problem that you are handling. And you will see in the slides that you can also handle this using you can also construct. So when I said struct point ABC, you could also make an array of 3 points, each with 2 coordinate points. You could say struct point 3 instead of saying ABC, and then you would just take the inputs accordingly. So this combines with arrays very elegantly also. The other thing that you should remember is that this data entry can be a little complicated. So what we frequently do is we define essentially a constructor function that will do data entry. What does that mean? So instead of taking scanf a.x, a.y, we could do something like so. We could say, let's make a function, a constructor function for struct point. What it will do is it will take integer values as inputs and it will store them as entries of the structure that we are dealing with. So this will be a function that will return that will return something which has the data type struct point. So it will take integers as inputs, and it will say, let me just show you, struct point temp, and we'll say temp dot x equals the integer x, temp dot y equals to the integer y, return temp. So we have a constructor function now. And then how will we use this constructor function? So instead of saying this, we will say int x comma y, and we would take x and y as inputs, and we would make point x comma y. So we have a constructor function, and now we are using a couple of temporary integers to take the input for all the points, and then we are using the constructor function to actually pass the input. You can also pass the struct point, the structure, as an argument in a function. We've already seen that by value. This is we're passing it by value. You can also pass them by reference, and so on. So let's consider the first problem now that I was going to show you from these problems. Now in this problem, we have the following requirement. We have to say whether an interval overlaps or does not overlap. And the logic is that the intervals overlap if they have some point that is contained in both the intervals. So we want to design a data structure that has two fields, the left and the right boundary. So essentially, given two intervals, you have to figure out if they overlap or not. It's a very simple problem, but let's work through it, and we'll have a better sense for it then. Let me make this happen. So we will make something called easy.c, and let me put in the boilerplate before we continue. Before we go further, let me quickly check if anybody is asking any questions in Zoom. No. What about in the live stream? No. Okay. So now we have this easy.c, and we'll say int main return 0, and we also know that we will need a structure that is of type struct interval, and it's going to have int left, int right, and now we need a constructor function for this. So let's try doing this a different way. So in this case, I'm going to pass the structure by reference instead of by value. I already showed you how to pass it by value. Now I'm going to pass it by reference, just so you can see how this is different. So because I'm passing by reference, this means I'm going to go to the location of the interval, and I'm going to set the points there. So I will pass a struct pointer. And I will pass the two integers that I'm interested in setting. And then what will I say? I will say so I have passed, what have I passed? I have passed a pointer. So I will say star interval dot left equals left, and similarly I will say star interval dot right equals right. So what am I doing? Let me close this buffer. What am I doing? I am passing the pointer that is pointing to the structure interval. Then I'm saying set the value stored in this location, the location that is pointed to by this pointer. So I say let us set the location, the address, let us change the value stored in this location to the value contained in left and right. That makes sense? Oh, actually this should be, sorry, this is what it should be. So what is this expression going to do? This is going to say the structure stored at this address, the interval that I'm pointing to here, I'm passing a pointer, so I'm passing an address. What is the address that I'm pointing to? Where interval is stored. So now I dereference it using the dereferencing operator. So then this whole thing is going to give me the same thing as if I had passed that point by value and I had said that point dot left. The other thing that I can do, which you will also see in the slides, is that instead of using this notation, which is slightly clunky, I can use this notation. I can use the arrow operator. This is the same as if I was doing this. These two mean the exact same thing. Whenever you get confused because we've introduced a new notation, just remember that this means this, these two things mean the exact same thing. This means the same as this. This notation is just saying set the value that is pointed to in the structure in field left, set that value to this value. That is exactly what is being said here. So these two expressions evaluate to the same thing. Yeah, we have a pointer to the structure, and with that pointer we can say in the pointer or in the entity that is stored at this address, find the left field and store this value there. Or I can say find the entity that is stored at this address. Now I have found that entity, that is a structure with fields left and right, and in that I will use the dot notation to find the field. So they both work the same exact, they're both saying the same thing. Don't be confused by the arrow notation. So now I have this arrow notation, and I'm saying I'm using this to construct the constructor function that is going to set my points given integer inputs. So then I will go back into my main function and I will actually take those integer inputs. I also need the intervals, struct interval, let's say a comma b, so it can be anything. And now I'm taking my integer inputs. For the first one, oops, so what do I say? I'll say x comma y, and now what do? I will set points. I will set, what do I set? I will set a comma x comma y. No, why will I not do this? Because I have defined a as a variable of data type struct interval, but I am passing it by reference. When I'm passing it by a reference, I will send the address at which a is stored. So I will pass the address of a, not a. Why? Because I am passing the structure by reference. I send the address. At this location, change stuff. That is why I have void as the return type. I'm not returning anything now. Now next, I will use the same logic again. for the other interval. And so I have now set the values for both intervals, and now what do I need to do? I need to say, do they overlap or not? So I will say if, and then I'll check the intersection. If check intersect A comma B, print overlap. Oh. Else print no overlap. And that's it. My code is ready. Except that I haven't yet defined this function, the check intersect function. What will this function look like? It will return an integer, obviously. I'm just doing a boolean check, and then I will say struct interval A, struct interval B. I have two formal parameters, both are of type interval or struct interval. And then what am I checking? I'm checking if there is an overlap. It has to be a bidirectional check, so I will say if A dot right is less than B dot left, or B dot right is less than or equal to A dot left, return 0. In this case there is an overlap. Else return 1. That's it. Now I am able to check for overlap. So now let's run this and see what happens. Hopefully there is no compilation error. Oh, good. Now what will I do? I will run it, test.exe. What are my points? Let's say they are 10, 20 and 30, 40. Good. So it says no overlap. Let's try this again. This time I'll say 10, 20 and 15, 30. There is an overlap. Let's try this one more time. Oops. Let's say it's 10, 20, 20, 30. There's an overlap because we're treating these as closed intervals. And just one last time, minus 10 to 0, minus 5 to minus 2. Yep. So it works out. Now this is a very straightforward problem to solve once you are able to solve the triangle inequality problem. And in these two problems I've shown you how to pass structures by value and how to pass them by reference. These are two things that are important to master before you move forward to handling dynamic data structures like linked lists and so on. So let's not touch linked lists today. We'll touch upon them later, and before we do that I'll also show you some other problems with static structures. So let's stop here today and we'll pick this up again on Friday at the same time, and then we'll keep going, and hopefully over the next 2 or 3 weeks we'll be able to cover everything that we want to cover in the in the in the programming portion of this course. All right, so let's close for today, and then let's pick this up on Friday.